today our structure is 3-methylpyridine. This is the structure here. It has a molecular formula of C6H13N, a molecular weight of 99.17 grams per mole, 1 degree of saturation, and 20 sigma bonds, being the nitrogen and the carbon and carbons, and the hydrogens attached to each of the carbon and nitrogen atoms, respectively. It has a 2-degree amine functional group, being this nitrogen here, and since it has 2 carbons attached to it, that makes it 2 degrees. It has a boiling point at 125 to 126 degrees Celsius, and a physical state at 25 degrees Celsius is a liquid. So, the carbon hybridization, there are only one type of hybridization, and that is the 6 sp3 hybridized carbons. And then the one heteroatom is the nitrogen shown here. Classifications of the carbons are, there's the CH3 being here at the end of the methyl group, one CH group being right here, and then the rest of these carbon bonds right here are CH2 groups. There are 6 unique carbons and 7 unique hydrogens. So we are going to make this molecule in just a second. Okay, so to make 3-methylpyridine, we're going to make the inner ring first. So we're going to use this nitrogen being represented by the blue snatom and the carbons represented by these black snatoms. So we're going to attach 5 carbons. So this is what it looks like so far. And then this carbon here is a methyl group, so we're going to attach this methyl right here. So this is what we have. And so now we're going to attach the respective hydrogens. So nitrogen gets 1, these CH2 groups get 2 carbons. So this is 5 as well. And since this carbon here has 3 other carbons attached to it, it only gets 1 hydrogen. And so then finally this methyl group here gets 3 hydrogens attached to it. So this is the completed molecule. So it has, let's go over the information again. This molecular formula is C6H13N, 1, 2, 3, 4, 5, 6 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hydrogens, and 1 nitrogen being here, 1 degree of unsaturation here. 20 sigma bonds attached to all of these atoms, and 1 functional group being the 2-degree amine functional group here, being this nitrogen attached to these 2 carbons. 6 sp3 carbons, hybridizations, 1 CH3 here, 4 CH2s being here, 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 and here, and 1 CH group here. So, and 1 heteroatom being this nitrogen here. So that is all. I thank you all for watching, and I hope you have learned something today.